Okay.
So,
what we're gonna do is we're first gonna create an electrochemical cell with zinc and copper. All right. So
let's get some zinc and copper.
yeah, let's get some zinc and copper, Mike.
This looks like zinc.
I'm gonna set up the solutions. Okay. So you're gonna need your you're gonna need to go to the tap and you're gonna get your
the tap.
You're gonna so here's your two metals right here. Okay. And you're gonna get your 0.05 molar solution of copper 2+ and zinc 2+. All right. So you got them both here. Put them right here. Okay. Oh no, he's so sorry. My mistake, they're over there. So, okay, you're gonna. Okay. Anyway, you're gonna put your metals in the solution.
In the solution.
Yeah.
We don't want to put it in.
Yeah, we're not gonna put it in. We're gonna pretend it's in there because that's gross. And then we'll put it in this one. And okay, so you're gonna have those two in their respective solutions, okay? And you're gonna write out the electrochemical cell in notations that you know which one to hook up the each end of the voltmeter to. So you're gonna.
I'll go grab the voltmeter.
Yeah. Okay. So while he's grabbing the voltmeter, all right, we're gonna explain this, okay? Because electrons flow from the anode to the cathode.
Got my
Okay.
voltmeter here.
Voltmeter there, okay. So you got the voltmeter, all right. You're gonna have to connect. You're gonna connect the zinc to the anode and the copper to the cathode. Okay, so let's do that right now.
You guys watching?
Okay, and the only thing left to do now, all right, is we're gonna set it to 0.02 for just fine measurement, okay. And then we're going to connect with a salt bridge. And, oh look, it's working!
It's working, guys, look.
Look, see, the voltmeter reading is something around, you get a number of some sort, and
A number.
if you get letters, you're doing it wrong.
Yeah. If it's negative, just switch
the electrodes around, okay? So, and by electrodes, I mean just the clamps. You don't need to do anything else, okay? Cool. You write that down, do your shit, and then you're good, okay? Awesome.
That's part 1.
Alright, part 1. Okay, now part 2. Very similar. You have almost the same thing, except...
It's another copper one, right?
Yeah, it's, instead of having zinc and copper, it's just 2 coppers, okay? So, these are both copper, okay? So, one of the solutions, you can, so you're going to need 2 new solutions, so dump them out. You're going to make one that is, alright, we're going to have one that is 0.05 molar solution of copper 2+. The other one
we're going to, it's going to be 0.05, but we're going to dilute it this time. Mm-hmm. And you need to do this in a
serial dilution.
Yes. So just pour some water in, I guess.
Yeah, so you're going to pour water just like you said in your pre-lab. You're going to do it just like you wrote out in your pre-lab in the flow chart, okay? And once you've done that, you're going to have your 0.00005 molar solution of copper. Okay, so you got it in that one and that one, alright? You're going to attach, since electrons flow from, they're going to flow from, I believe it's concentrated to, it's concentrated to dilute.
No, dilute to concentrated.
Oh, right, whoops, yeah, dilute to concentrated, whoops, my bad.
I guess
So,
we're going to test.
yeah, they flow from dilute to concentrated, okay? So you're gonna, again, connect the anode and cathode accordingly, okay? So, let's do that, and hook up your voltmeter again. Oh! And you're getting a reading.
We're getting a reading.
You're gonna do your percent error calculation on this one again. It's gonna be very crappy because this cell's very finicky. Cool.
Yeah, that's so.
It's a shit cell.
Okay, so that's part 2. Okay, so for part 3, you're going to be given a voltage by your TA.
Here, Michael, here's the voltage. Cool, alright, go do shit.
Thanks, TA. So let's pretend the voltage we were given is 0.041. You're going to look at your pre-lab, and the voltages you already determined. You find the one that's closest to 0.410. It's apparently a zinc and a copper one.
Yeah, it's gonna be so it's gonna be actually it's 1.103 or something like that. Okay, cool. So you're gonna dilute one of the solutions. You're not gonna dilute both. You're only gonna dilute one.
First of all, though, you want to just test to see how close it is to start off.
Yes.
So let's put. So this is the zinc. This is the copper. So we put them in, and we get a reading. Oh, it's like.
It's 1.103. Yeah.
Yeah, not even close to 0.41.
Yeah, it's just like your tabulated value. Okay, so what you're gonna do is you're gonna find out which one you have to dilute and by how much using the Nernst equation, and you're just gonna solve for Q. Okay, so solve for Q in the Nernst equation, and then take like Q as product over reactants, right? Substitute either product or reactants as 0.05, and then solve for the other one, and you'll get what you have to dilute the other one to.
Yeah.
Right? If
Easy.
Easy, right? Easy peasy.
No big deal.
So, once you do that, and then you perform a dilution on one of them, you're going to connect the cell up again, hopefully get a good reading.
Yeah. Oh, we're going to try it now, since we diluted it.
Yeah, dilute it with water.
Yeah.
Put the stuff back in, connect, turn it on.
Oh, look. 0.41.
Oh!
What are the chances, right?
Cool, right, we got it. Perfect. That's 0% error, isn't it?
0% error.
0% error, you probably won't get that.
No.
So, it'll actually be quite fine. Anyway,
so after that, all you need to do is just, well, you've been keeping track of what you guys have been doing, so just write down that in your procedure.
Yeah, you just write down exactly what you did, what stuff you decided to get, right? Like what you needed for each cell, right? And then write how you diluted it and by like which amounts. Don't skimp out on details or else they'll dock you for it because it's the biggest part that they mark you on, or second biggest. And then
don't forget, and then you're done.
Oh yeah, and make sure to show your in your calculations part. For 1 and 2, you're going to be doing percent error for like how far off you were from each cell, and then for the third one, you're just going to calculate. You're going to show all your calculations for like how you solved for Q and then what you need to dilute.
In other words, a shitty lab.
Yeah, it takes a long time. You guys
are screwed.
Are you going to open up to questions?
No.
Hey Mike, what's on your lab coat?
Oh, it's the stuff from the equilibrium lab's kind of gross.
Cool.
Doesn't watch it.
A lot of it then.
Bye.